Good morning, everybody. Sorry that it looks like the LMS is down, so I'm just going to send you guys this recording for today of what we were going to go over during our live class connect session. So if you have any questions, concerns, comments, please send me a K-mail, and I'd be happy to answer those this way. So in your head, but on your own now, since you can't type on the screen, explain how heat moves from one object to another. So we know that heat can be transferred. It's moving from objects in several different ways that you learned about in one of your lessons. I believe it was on Friday that you learned this. Um, and there are three different main ways that we're going to talk about that heat is transferred. So we'll just get right into it. Just some important information about this week. First of all, make sure that you are always checking the announcements tab on the home screen. So you'll see week blank at assignments and due dates. I always highlight in red the current week. You'll need to click, there will be a plus sign right here, and you'll click it, and that'll drop down all of this important information for the week. So make sure you're checking that weekly. So during the Class Connect session, I was going to pass out the Unit 5 study guide. I will just attach it to this K-mail that I'm sending this link in. Thursday's optional Class Connect session. So on the 6th here, if you would like to attend at 10 a.m. On Thursday, I will be reviewing the answers to the study guide for the Unit 5 test. And you can turn your study guide in for extra credit if you submit it to the Dropbox by 9 a.m. on Thursday, November 6th. So I will not accept it after 9 a.m. on Thursday. So make sure if you would like to receive the extra credit that you are submitting that assignment to the Dropbox by 9 a.m. And also make sure you're coming to the optional Class Connect session that will be at 10 a.m. on Thursday to hear the responses, the correct answers to that study guide so that you can prepare for the Unit 5 test. And I will actually give you guys time on Thursday to start the Unit 5 test if you'd like, and it will be due at 11:59 on Friday. So I highly recommend, I know I say this every time you guys have a test, but you need to try to take the test as early as possible just in case you run into technical issues. If you're emailing me at 9 o'clock at night on Friday the 7th, it'll be difficult for me to help you at that point. So make sure you can take the test on Thursday once you finish the Design a Thermos lab. You'll be ready to go for the test. So I would recommend taking it actually on Thursday. So if you do run into technical issues that you'll be able to reach out for help before it's too late. Okay, so today we're going to be talking about how heat moves, and we're going to be discussing the heat transfer lab. So the three ways that heat moves are through conduction, convection, and through radiation. So we know that heat is produced by molecules moving, and then the different ways they're transferred are those three right here, by conduction, convection, and by radiation. So those are different ways that this movement of molecules is causing the heat to transfer to other places. So when there is a temperature difference between two objects, the heat is always going to move from a high temperature to a lower temperature. So you may remember from biology that the concentration gradient is the movement of particles from a high to a low concentration. Well, heat moves in the same way. So in a warmer place, it's going to then move to a colder place. So if I am walking outside in one of those freezing cold days, I don't know if some of you guys live up north where it was actually snowing on Friday. Oh my goodness. But if I walked outside without a coat on, I have a warmer internal temperature than outside. Okay, so if my internal temperature is, say, 98 degrees and I walk outside into 30-degree weather, then the heat from inside of my body is going to transfer away from my body to the lower temperature of outside, which is then making me cold. Okay, so when heat is leaving my body, it makes me feel chilly. Also, if you think of an ice cube, if I hold an ice cube, my hand that I'm holding the ice cube with has a higher temperature than the ice. So the heat from my hand is going to leave my hand and go into the ice cube that has a lower temperature, which will then cause the ice cube to start melting, and that's what causes my hand to feel cold. So Olaf, when he got to experience spring, if you guys have seen Frozen, the heat is moving here. Olaf is cold and the sun is hot. So the heat is transferring from the hot sun to chilly Olaf, and eventually Olaf's will start to melt because the heat is being transferred from the sun to his cold body, and then causing it to then heat up. So we were going to do a matching activity here between the different types of heat transfer, and then how exactly they're moving, but I will go through this for you guys today. So for conduction, remember in conduction, it happens when molecules are colliding. So if I am holding a warm mug, then the molecules inside of that warm mug are moving very, very quickly. Remember, as you heat up molecules, they move faster and faster, and then that heat is transferring to my hand that has molecules in it as well that are moving a little bit slower there. So when the molecules are moving and colliding, we are talking about conduction. Okay? Convection, on the other hand, is talking about fluids. So if I boil a pot of water, then the warmer water is going to rise to the top, even though the burner is on the bottom of the pan or the pot. The heat of that fluid will eventually rise to the top, because remember, just like air, warm water rises, heat rises. So the warm water begins to rise to the top of the pan and the cooler regions will sink. Well, once those cooler regions sink and they're closer to the burner, they'll start to heat up and they'll then rise, and this is causing kind of a circular motion to happen, which we're going to call currents, and that is how heat is transferred through convection. And then last but not least, we have radiation, which is heat transferring through electromagnetic waves through an empty space. So if you're having a nice bonfire, roasting some s'mores, roasting marshmallows, and I don't like when my marshmallows get burned, so I always hold them pretty high above the fire. I like when they're just that toasty, golden brown, not burnt to a crisp. So when I'm holding them nice and high above the flames, then the electromagnetic waves are moving through that empty space. They're moving through the air and going to my marshmallow to brown it nicely for me. Same thing with the sun. The sun's heat energy it's not moving through molecules, right? There's no molecules colliding in that empty space. The heat is moving through just electromagnetic waves through that empty space to warm the earth. So in our lab, we are going to explore how heat moves and then attempt to slow it down. So remember, heat moves from areas of warm to areas of cold, and some materials we learned also block heat better than others. So we learned about conductors, which are materials that conduct heat very well, such as metal. So if we made a pan, that's why we make pans out of metal, Teflon, things like that. They conduct heat very, very well. Heat can transfer through them easily. And then we have poor conductors that we call insulators. And those are things we actually use to keep things warm. So we use insulators in our house to make sure that the heat can't escape and that the house stays warm. We use insulators in our coats to keep us warm so that the heat does not escape our body. So I want to make sure that that's very clear, that these are opposites from each other. Conductors, if we made a coat out of metal, then the coat would not work very well because it conducts heat. The heat would transfer quickly from our body and leave our body and go to that metal, which would then make us cold. Where an insulator, the heat does not actually conduct heat very well, so it would keep the heat inside of our body so that it doesn't leave our body. So that's why we use insulators in coats, because it'll keep the heat inside of our body. It will not allow the heat to escape our body to the colder air outside, which would then cause us to be cold, like which happened for poor Olaf when he went outside. Okay, so I want you guys to pause this video and make a hypothesis about what you think is going to be the best conductor and what you think is going to be the best insulator. So remember, for our lab, we are looking at what is going to, so we're exploring how heat moves and we're attempting to slow it down. So what you'll do in the lab is you'll actually take these materials and you'll place them on a hot plate, and you'll put an ice cube on top of those materials then and see which material causes the ice cube to melt faster. So that would mean which of these materials is a better conductor. So remember, you want to use an if-then statement. So for example, if I said, if I put aluminum between the ice cube and the hot plate, then the ice will melt quickly because aluminum is a good conductor. Or maybe I said, if I put fiberglass between the ice cube and the hot plate, then the ice cube will melt slowly because fiberglass is a good insulator. It does not conduct heat well. So go ahead and pause the video and write a hypothesis for each of these different materials. Okay, so hopefully you paused and are done writing your hypothesis. So what you're going to do is you'll use the results from the lab today for the lab that you're doing on Wednesday and Thursday. So you actually don't need to submit anything for today's lab. You just need to complete it. You need to determine which of these materials is a good insulator and which of these materials is a good conductor. And then you're going to actually design your own thermos tomorrow. It's a pretty fun lab. So you'll decide what materials are good insulators and good conductors for your thermos, and you need to decide, am I going to use the materials that are really good conductors for my thermos, or am I going to use materials that are really good insulators for my thermos? Because remember, for a thermos, you want to keep the materials inside that thermos nice and warm. So you want probably a good insulator so that the heat would not escape the material. Let's say you put soup in your thermos. You don't want the heat to leave the soup and go to the colder air outside. You want the heat to stay inside of the soup so it stays nice and warm. So you're going to want to find the materials for your thermos that are good insulators. And you'll use your results from today's lab about these different materials to determine which of these materials would be the best insulator to keep whatever material or liquid is inside of your thermos warm. Okay, so I'm going to send out the Jumpstart for you in your Kmail, since you won't be able to click the link from this YouTube video. But I just want to draw your attention back here to make sure that you are completing the lab today. Again, you will not have to turn anything in for it, as you see down here, but you will use these results from this lab to design your thermos, and then on Thursday you'll turn in that assignment. I would highly recommend trying to finish your thermos lab tomorrow, and then that way that'll open up all of Thursday for you to just spend studying for the Unit 5 test, because this design a thermos lab should not take you 2 days really. You get 2 days to complete it if you need them, but you should be able to complete it tomorrow and then spend Thursday studying for your Unit 5 test. Also, just remember, I'll attach the study guide to the Kmail. And if you would like extra credit for it, then submit it to the Dropbox by 9 a.m. on Thursday. And please come to the optional Class Connect session at 10 o'clock on Thursday so that you can review for the Unit 5 test. And then I will actually push you guys out to the test on Thursday so you can do it that day, to make sure that you, if you run into technical problems, that you have time to ask questions and things like that of me without having to submit your test late. So if you have any questions at all, please do not hesitate to Kmail me. I'm sorry that it didn't work out having this session again this week because of LMS issues, but I hope to see all of you on Thursday. Hopefully Class Connect will be working for us on Thursday and we can chat during the live session and I can answer any questions there as well. But don't hesitate to reach out to me through Kmail, and have a great week, you guys.